In this video, we're going to take a look at one of the hardware architectural metrics according to ASIL 26262, the PMHF. We're going to look at what a PMHF is, how to calculate the PMHF, and then we're going to do one example of how to calculate the PMHF. So one of the important hardware architectural metrics that the ASIL 26262 recommends is the probabilistic metric for hardware failure, also known as PMHF. By definition, what the PMHF is to ensure that the residual risk of safety goal violation due to a random hardware failure is sufficiently low. What that means is, in a system, you're going to have several sensors, you're going to have several control units, you're going to have several actuators. Some of the sensors can lead to a failure that can lead to a violation of safety goal. Same thing with the actuators, same thing with the control units. What is the probability that any of these components can fail and this can lead to a safety goal violation? And we want this probability to be as low as possible. Lower the probability, the less likely it's to fail, the more safer the system is. Now, this is the idea. How do we make sure that it's low? Now, there's two ways of going about this. Number one, it is to ensure it's called as a failure rate class analysis. So what we're doing in a failure rate class analysis is we're going to look at individual components. We have a sensor, we have sensor 1, we have sensor 2, we have actuator 1, we have actuator 2, we have the control unit, it has 7 components. Take individual components. Depending on what the highest ASIL safety goal that is violated, and depending on the failure rates of individual components, and what diagnostics we have, we develop a qualitative argument in terms of what failure class does this component belong to. Again, we're doing this for individual components. Now, this method is not a very popular method because there is a lot of subjective argument around this, which is why we want to use a second method of calculating the PMHF. Calculating the PMHF is taking into account the overall failure of the entire system. What is the probability of failure of the entire system? And then looking at what are the biggest components, or what are the biggest components that lead to failures. So for this rest of the video, we're going to talk about method 2, which is what is PMHF and how to calculate this PMHF. We're not going to focus on method 1. Now, PMHF is defined as the average probability of failure per hour over the entire operational time of the item, which means what is the probability of failure, a probability of failure that can lead to a safety goal violation or hazard over the entire lifetime of the vehicle. It could be a vehicle in this case, it could also be a robot. Item here represents the vehicle, the robot, or it could be a subsystem inside the vehicle. And the PMHF is defined in terms of fit or failure in time. The unit is called as fit. So one fit is 10 to the power minus 9 failures per hour. What that means is you have for every 1 hour of operation of a particular component, the probability of failure is 10 to the power minus 9, which in other ways can be defined as one failure in a billion hours of operation of that component. Again, 10 fit is 10 to the power minus 8 hours of failure, 100 fit is equal to 10 to the power minus 7 hours of failure. So our goal here is to in terms of fit, define in a given system that we are building, what is the probability of failure of our system. Before we go into how to do this, let's look at what is the metric that we need to achieve. Now, if we are building a system according to ASIL 26262, there is a recommendation as to what the failure rate should be. If it's ASIL D, the target should be is that the overall probability of failure should be less than 10 to the power minus 8 per hour, which is 10 fit. If it's ASIL C, it should be less than 10 to the power minus 7 per hour, which is 100 fit. Same thing with ASIL B. So which means the sum probability of all failures in the system for an ASIL D safety goal should be less than 10 fit. The sum of probability of all failures of the system for an ASIL C safety goal or an ASIL B safety goal should be less than 100 fit. So this is the target we need to achieve. Now, how do we do our calculations to achieve this target? Well, first of all, there is a formula for this. That there is total probability of failure, and this total probability of failure should be less than 10 fit or 100 fit, depending on the ASIL. Now, let's break this formula down. This formula consists of three components. There is a lambda SPF, there is a lambda RF, and then there is this bigger component.